So here is a question that wants us to find all roots of this polynomial without using a calculator. Now that can be a little tricky. However, we have something called the Rational Root Theorem, which states that all rational roots must be in the form of p over q, where p is an integer factor of the constant and q is an integer factor of the leading coefficient. Now what does that all mean for our polynomial? So let's explain that a little more clearly. So first I'm going to set up a column for p, a column for q. Now q is the variable given to your coefficient or your factors of your coefficient of the leading term. So our factors here are 1 and -1. Then we have a look at p. P are your factors of your constant. So here we have -3, 3, -1, and 1. So what we need to do is work out p divided by q and then substitute that value in to see if that in fact is a root. So first of all I'm going to do p divided by q when q equals -1. So -3 divided by -1 is 3. 3 divided by -1 is -3. -1 divided by -1 is 1, and 1 divided by -1 is -1. Now I'm not going to do the other q value of 1 because it's just going to give us the reverse of all our answers, which means we just end up with the same set of values. Now to find if these are roots, we need to substitute them in for x and see if they equal 0. So let's do -3 first. So -3 cubed minus 3 times -3 squared minus 3 minus 3. We end up with -27 minus 27 minus 6, and this does not equal 0. Therefore, -3 is not a root of the function. Let us now try the value of 3. So 3 cubed minus 3 times 3 squared plus 3 minus 3 is 27 minus 27 plus 3 minus 3, and that does equal 0. Therefore, 3 is a root, and our factor is always the opposite, so x minus 3 is a factor. And we can use that now to then find the other roots. Okay, so we know that x minus 3 is a factor, so we need to divide by it in order to find the others. So I'm going to use synthetic division, which means I'm dividing by 3. I'm going to put the coefficients of every term in here. And just double check that they're in order. The exponents are in decreasing order, going down by 1, and they are, so we don't have any gaps, so no need for any zeros. Okay, now this coefficient always just drops to the front, and then we start our very repetitive process. 3 times 1 is 3, and then we add the column. -3 plus 3 is 0. Multiply. 3 times 0 is 0, then add this column and we get 1. 3 times 1 is 3, -3 plus 3 is 0, and we are finished. Now initially this one represented x cubed, so our answer is x squared. It is always 1 less than the value of the exponent. So x squared, I have 0 x terms plus 1 and 0 remainders, so we don't need that. Then this just looks like x squared plus 1, and of course I've still got my other factor of x minus 3. And they are our factors, so we need to find our roots. To find our roots, we can make this one equal 0. X squared plus 1 equals 0, which means that x squared equals -1. So x equals the plus or minus root of -1, and we know that the square root of -1 is I. So that is plus or minus I. And this one we can also make it equal 0 if you need to. Or you can just see that x is going to equal 3. So our roots are 3 and positive and negative I. If you wanted the factors, then that's the linear factors, because remember all polynomials can be written as linear factors. we have x minus 3, x minus I, and x plus I. And they are your factors. And if you wanted to double check, you could multiply these back out and you'll end up with the original polynomial.